Hi guys, good morning. Today we're going to take a look at pages 8 and 9 of your classwork packets. We're not going to do the entire thing, just a few bits and pieces that are important. Once again, that's pages 8 and 9 of your classwork packets. Now, I know that there's a fair bit of blanks here. We're not really going to go through and fill them all in because it's really a lot of mumbo jumbo that can be simplified to something quite nice. All right, here's the basic deal. Okay, in a circle, if we have a chord, remember what a chord is, right? A chord is really just a segment that happens to have both endpoints lying on the circle. And what we need to know about them is that if they are congruent, so if they have the same length, what it means is that these arcs that they intercept, which basically means the arc that goes around it, right, are also going to be the same. The converse also holds true, which is a fancy way of saying if these two arcs are the same, that means that their chords are also going to be the same as each other, all right? So in other words, if the chords are the same, their arcs are the same. If the arcs are the same, the chords are the same as well. All right? With that being said, let's take a look at a few examples. All right? So the first one we're going to do is quite easy. We're going to take a look at page 8, number 1. So page 8, number 1. Okay? Now, this one right here, well, let's take a look. Meh. Meh. There's the center. There's a chord. There's another chord. And look what they tell us. They tell us that these two chords are congruent, and they tell us that using tick marks. Now, what do we know about congruent chords? What we know is that congruent chords intercept congruent arcs. So if these two chords are the same, so are these two arcs. So if they're the same in algebra, what does that mean? We set them equal to each other. Okay? So at this point, it becomes pretty much just a couple-step equation, right? So let's see, that's 5 minus 4, which is 1. That turns into 11. So 7x equals 91. Divide both sides by 7. X equals 13. All right? So that would be question number 1. The other example I want to take a look at, because it's a little itty-bitty bit different, is on page number 9. What page? Page number 9. And I want to take a look at number 5 because that one is going to require you to use a little bit of stuff that we talked about last time. All right? So page 9, number 5. Apologies in advance for the bad handwriting, but, hopefully you're listening, so that's not such a big deal. Okay? All right, so I got a center. I got a chord. Congruent. 6x minus 20. And they tell me this right here is 76. All right, so here's the kicker, right? Notice how I have this arc, I have this one, but I don't have this one over here. Does anybody have any idea what an expression might be that I could use for this piece? Well, congruent chords have congruent arcs, so if this is 6x minus 20, what would this be over here? Oh my gosh, 6x minus 20. Now before, how many degrees do we learn there are in a circle and also going all the way around it? 360, right? So that means, what do you guys think my equation would be? You guessed it, 76 plus 6x minus 20 plus 6x minus 20 again equals 360. Now I'm going to do some combining like terms for us, all right? So I get 12x, 76 minus 20, that's 56, that's minus, plus 36 equals 360. Then it's really just a two-step equation, right? So I get 12x equals 324. Do some division, and I'm going to be really brave here and do this without a calculator. Right, of course. So minus 24, and I get 8. So I think it's 27. All right? So in other words, this particular concept is very, very simple. If I have congruent arcs, they have congruent chords, okay? Or if I have congruent chords, I have congruent arcs. And as you saw with this problem, it may be assessed a little tiny bit with some other stuff, like the fact that there are 360 degrees in a circle, but overall, pretty darn simple.